The world was absolutely blown away, pun intended, when Frohr Systems came out of stealth after 4 years of building a solid-state cooling system that sucks a lot of air. Look at this thing. And here we are, 6 months later with everything basically fully uncovered. They've got multiple solid-state cooled PCs, torn down Airjet Minis for us to peek inside, and they're even teasing a more powerful version with double the cooling capacity. And here's double the segue to our sponsor.
XSplit. Looking to take your video streaming to the next level? XSplit is a software company that provides simple yet effective broadcasting and video production tools. Check them out at the link below and use code Linus for a very nice 69% off your first purchase or subscription.
At risk of sounding offensive, it doesn't really look like much. They've got a flat copper bottom that sits on your CPU or SoC, any heat generating component. On the top, you've got these kind of paper filters over the intake, flexible PCB that goes into their drive system, and then at the back, there's a tapered section that leads to a skinny little exhaust. And it's there that the Unimpress completely disappeared. I mean, this thing hauls butt. They are blowing air at over 200 kilometers an hour through those filters and blasting it onto the copper plate. But here's the thing. Moving air is just a means to an end. It's only part of the battle. We don't really want to move air. What we want to do is remove heat. Let's take it apart to see if we can get a better understanding of just what's going on here. I cannot believe they're letting us do this. Here's the completed cooling module, which I've shown you already. And here it is, completely torn down into its constituent components. It starts with, yeah, this really is just a sticker. 4 little paper filter windows in it, okay? And then we get into what I would call the cooling engine. It uses piezoelectrics, and we did a full video about this recently, but basically a piezoelectric material vibrates when you apply an alternating current to it. So what you're looking at in the top is these intake slits that pull air through those filters, okay? Then out the bottom, they've got all these little jets that blow down onto, here's the last component, this kind of crappy flat copper spreader. I mean, okay, I get it. You want to keep this thing thin. It's just 2.8 millimeters, and that's critical for getting the design in thin and light devices like laptops. But every cooling plate that I've ever seen that doesn't totally suck has got fins or other structures to help increase the surface area. What is going on here? To find out, we need to go back to the cooling engine, or the cooling chip as they call it. On the underside, there are 80 small openings called impingement jets. They were only willing to let us open up an older prototype that has twice as many, but you should still be able to get the idea here. And these jets are a huge part of the special sauce that makes this cooling solution so unique. We've shown many times in the past that there are diminishing returns as you blow air faster and faster over a heatsink. This is because of something called the boundary layer. Check out this illustration from Wikipedia. You see, no matter how fast your air is moving sort of near a heatsink fin, the speed of it is always going to approach zero as it reaches the actual fin, and this is due to friction. What happens then is this creates a blanket of insulating air that prevents heat from being removed from the fin efficiently. Well, what Frohr has done is they've used these jets of super high velocity, high pressure air to completely obliterate the boundary layer. This increases effective heat dissipation by about 5 times for the same airflow and functionally saturates the air with heat, bringing it up to nearly the same temperature as the copper heat spreader. Now, an Airjet Mini is good for about 5 watts of cooling at room temperature, assuming the die is at about 85 degrees. So naturally I asked them, well, couldn't you just take a bunch of these, throw them on a vapor chamber and of course, they've already done that. This Samsung Thin and Light right here has been modified with 3 Airjet Minis for a total of 15 watts of active cooling on top of the passive dissipation through the chassis. Now, they could have put a 4th one on here, but this machine wasn't designed in collaboration with Frore, so they had to improvise a little bit. And as you can see, there's some PCB there that wouldn't very much like to be chopped off. This is such a good demo here because they've got their Frore modified laptop here running right next to an unmodified one, showing some key benefits. So first up, check this out. Using our thermal camera, we can actually see that if we look at the exhaust temperature behind the system, our Frore is at about 41 degrees, while the regular cooler is at about 35. This can be partially explained by the heat saturation of the air like I talked about before, but part of it is also that our Frore laptop is running about 10 degrees hotter. Wait, but that's a good thing. Let me explain. In many laptops, the performance limitation is actually not the temperature of the CPU or the SoC. Rather, it's because of the external temperature of the device. Anything above about 45 degrees Celsius will eventually burn the user. So thin and light laptops will already throttle performance if the hotspot on the bottom exceeds this level. That is where the AirJet's second big party trick comes in. Aside from not needing a fan, it is extremely high static pressure. Frore Systems claims that an AirJet Mini manages about 10 times the static pressure of a MacBook Pro cooler, over 1700 pascals. That allows it to suck air through restrictive openings much more effectively than a conventional fan, which improves cooling not just of the CPU that it's installed on top of, but of the entire system. So, because the skin temperatures of our two laptops are so different, the Frore Systems CPU is actually operating at 33% higher power. That is going to have a dramatic impact on performance. That's why the chip is running hotter. Another advantage of the high static pressure is dust resistance. Typically, a laptop can't be both actively cooled and dust-proof unless you create a separate compartment for the fan and heatsink, kind of like what they do in some rugged machines. That is not a great solution for a thin and light. But with the AirJet, there's the dust filter that's on the AirJet module itself, and you can also use that pressure, that suction ability to install dust filters on the intake of the device without trashing your airflow. So you could have it pull air through a filter here, put air through another filter here, and blow it out the back, cooling the entire device. And the best part, they built in a reverse blast out cleaning solution for the filters, so they should last 5 years and beyond without getting gummed up, even though they're just basic paper dust filters. This dust resistance is what made the AirJet perfect for their first commercial product, the Zotac ZBox Pico with AirJet. This mini PC is intended to be used on factory floors where dust and debris could easily clog up a normal fan-cooled device. Now, in the past, Zotac got around this by just passively cooling the CPUs in these devices, but that limited them to a 5-watt Celeron processor. With this dual AirJet Mini solution though, they can now use a 15-watt Core i3, which takes them from 2 cores to 8. That is a massive performance uplift. And we can see the difference right behind me, where they've got one of these systems running passively. This is with the Core i3, showing how it's thermal throttling to hell. And then they've got the Frore Systems cooled model, where you can see the performance is a lot better. And this is still early stages. They're expecting to be able to get CPU power up a fair bit by improving the efficiency of the rest of the device. That is all really impressive and changes my question from why did you guys need to be in stealth for 4 years to how did you do this at all? As we saw in our piezoelectric fan video, ensuring that you hit the resonant frequency can have a huge impact on performance. And the thermal expansion of the vibrating membranes is enough to knock it out of whack, meaning that they have to constantly change the input frequency between 23,000 to 24,000 hertz to ensure that it's always operating at peak efficiency. That brings the full power consumption of each chip to just 1 watt at full tilt. That's not bad for 5 watts of cooling each. For context, that would allow you to handle a 15-watt system with 2 air jets and would cost you only about 2 watts of power for heat dissipation. That's almost identical to a small fan, like the one on the Steam Deck, which is 2.5 watts and takes up more space. But hold on a second here, Linus. When you guys showed off that expensive piezoelectric fan a while back, it had low power consumption, sure, and it was dust-proof, but it had none of these other benefits. Where was the high pressure? Okay, I'm getting there. You've heard me a couple of times refer to the AirJet as a chip. Well, I asked them, what makes it a chip? Like, does it have some onboard processing or something? The answer is no, but that doesn't make them big liars. Achieving the kind of one-way valve operation that gives this cooler such high static pressure, it takes a lot more than just a vibrating tongue depressor like we saw last time. So, like a chip, the AirJet is precisely manufactured using photolithography, the same process as you would use to build a CPU or a GPU. You coat the cooling engine layer by layer with photoresist, then expose it to light and etching chemicals and remove the unneeded material. This is inherently a 2-dimensional process, so the AirJet gets built up one layer at a time until we have our final little air blaster. Now, the manufacturing process is a big part of the reason that the AirJet is only going to be found in premium devices, at least for the time being, where you can justify that additional cost with the additional performance that it can unlock. Because see, the thing is, while photolithography is a well understood and fairly mature manufacturing process, especially at a relatively macro scale like this, Furore is working with entirely new non-silicon materials that required extensive R&D and brand new machinery to manufacture at any sort of scale. And high cost isn't the only bad news. While their demo here does a really good job of showing how the Furore system outputs less overall sound than the conventional fan, I found that the quality of the noise, that is, that it's at a bit of a higher pitch, made it significantly more noticeable. The good news is that there are clear paths to resolving at least some of these problems in the future. While the AirJet Mini outputs laminar airflow in order to make it quieter, this laptop wasn't designed with the AirJet Mini in mind, and it's blasting that air at the bottom of this hinge and the bottom of the screen, increasing turbulence and increasing noise. They can actually adjust the nozzle in a device that's built for their cooler to help alleviate this issue. And there's more. The roadmap these guys are showing looks extremely promising. When they went out of stealth at CES, they showed, what? The AirJet Mini? But there's more. Even at their current manufacturing node, so to speak, they can already build higher performance solutions. The AirJet Pro is twice the size and manages to remove twice the heat, about 10 watts, at only 1.7 times the power consumption. So devices like laptops could easily have a bank of like 4 of these sitting along the back, cooling up to a 45-watt chip as long as you've got a vapor chamber to spread the heat. And oh, the best part, man, you wouldn't even need a bottom intake anymore. So you could put your laptop down on your bed and it's not gonna overheat because you could just draw air in from anywhere. That is so cool. And it can be used on just about anything. Aside from computers, they're showing off LED light fixtures at like 1/10 the overall volume. They've got, oh, check this out. Actively cooled SSDs that are operating at, ow, okay, that one's really hot, the not for a cooled one. Smart, like IoT devices, like want to overclock your Ring doorbell? With an AirJet Mini, they figure you could do about 8 watts compared to the 3.3 watts that is allowed with the passive stock configuration. I mean, what's next? I'd love to see this thing modded into an ROG Ally or a Steam Deck. 2 minis should do the trick, right, Alex?
Oh, yeah.
Is that a project you guys want to see? Oh, what about in a phone? I mean, there's gaming phones with fans and water cooling in them already. Why not this? Black Shark? ROG phone team? You guys up? And what's really wild is this is all just with the current gen. Their material science folks do see a path to doubling their performance per unit area every couple of years for the next little while. We could see thin and light gaming PCs with 70 class NVIDIA graphics in just a few short years. And I'm not talking the cooling limited ones that we see today. I'm talking full performance. The main levers that they're going to be using to do this are higher amplitude vibrations and higher frequency vibrations, which makes sense. And so that, combined with if they can bring costs down, I mean, they wouldn't go as far to say it. See, they're not going to say it right now, but when I asked, are you guys trying to make fans just obsolete? I caught one of their technical guys nodding in the background. Huh? Yeah. It's not impossible that they could even get the cost competitive. You see, the thing is, a motor hub is always going to have a fixed cost because of, like, magnets and stuff. But if they're able to scale in a Moore's Law kind of way, well, let me put it this way. The hard drive industry thought it would always be safe from low capacity SSDs, and they cost so much. And where are they at now? Frohr says that their process is similar to TV panel manufacturing, where the larger they can get the mother glass, the bigger the panels they can build at lower costs. Well, that sounds pretty good given TVs have been one of the only things that's been inflation proof lately. So right now, yeah, the costs are high, but that's because they're operating at a very small manufacturing scale because it's so new. But that could all change. Just like this segue changed from what we wrote to our sponsor.
Sweetwater. When we need to upgrade our audio gear here at LMG, we can count on the fine folks at Sweetwater to carry the latest and greatest. Whether it's mics, headphones, sound mixers, preamps, or cowbells, they've got everything you need more of. Not sure what products you need? Use the comprehensive resources on their site to help guide you, or speak to a Sweetwater sales engineer for personalized gear advice. And with their total confidence coverage warranty, most of their products are covered for 2 years, with most repairs done on-site by their award-winning factory-certified service department. Sound clearer, crisper, and cleaner with Sweetwater. Check them out at the link below.
If you guys enjoyed this video, go check out our video on the piezoelectric fan that cost us $1,100. How far we've come in like 6 months? Was that 6 months ago? A year? Wow.